Okay, so we're on to the first of the mechanics questions, which is about a question regarding variable acceleration. We can tell that this is variable acceleration because the velocity here is a function of time. If I differentiated that to find the acceleration, there would still be a function of time in here. So let's just have a look, just to remind ourselves, for part A, then we know that to get acceleration we differentiate velocity. So A is the derivative, what we get when we differentiate velocity. So the first thing I'm going to need to do is differentiate 6t. Well, 6 times t is just going to differentiate to 6. So it's going to be 6i. And here, when I differentiate 5t to the 3 over 2, 5 times 3 over 2 is 15 over 2. So minus 15 over 2. And t, 3 over 2 take away 1 is t to the half. So t to the half j. So acceleration when t equals 4 is going to be 6i minus 15 over 2 t to the half, which is 4 to the half, which is root 4, which is 2j. So it's here I've got divided by 2 times by 2, cancel each other out, is 6i minus 15j. Notice it asks the acceleration, it doesn't ask for the magnitude of the acceleration. If it just asks for the acceleration, we give it as a vector. If it asked for the magnitude of the acceleration, we'd have had to use Pythagoras to find the absolute value of this. Part B, find the position vector when t equals 4. So part B, to find the position vector, we normally call the position vector r, is the integral of velocity with respect to time. So we're going to be integrating 6ti. Well, this is 6t to the power of 1, so we're going to need to up the power, so it's going to go to t squared, divide by the new power, 6 divided by 2 is 3, so it's going to be 3t squared I. Good practice in your head just to check that if you differentiated that you would get back to 6t. Now, I've made a common mistake already, so I'm going to just cross this out, which is that I've forgotten to put in my constant of integration. As soon as I integrate, there should be a constant. I'm going to see why that's going to cause me a problem in a second. So I'm going to cross out my I. I'm going to call my constant of integration here k, and I've got 3t squared plus ki. I'm going to need to do exactly the same thing over here. I'm going to do integrating 5t to the 3 over 2. Well, the 3 over 2 is going to add 1 to become 5 over 2, divided by the new power is going to be 2t to the 5 over 2. I'm not going to make the same mistake again. Let's just check. 2 times 5 over 2 is going to give me my 5, t to the 3 over 2, plus L j. Now, we're given our initial conditions. We're told that when t equals 0, the position vector is minus 20i plus 20j. That lets us work out the value of k and L. So r, given that t equals 0, equals, well, that's going to become 0. I'm still going to have my ki, and here that's going to become 0 minus Lj. Comparing that, I've got k equals minus 20 from up there. And here I've got plus 20 equals minus L. So L equals minus 20. So I can now say that R equals 3t squared minus 20 I minus 2t to the 5 over 2 minus 20j. Now, I'm trying to find when t equals 4, so r given that t equals 4 equals 3 times 4 squared minus 20 I minus 2 times 4 to the 5 over 2 minus 20j. Well, 3 times 4 squared. 4 squared is 16. 3 times 16 is going to be 48. 48 minus 20 is 28i. And here, well, 4 to the 5 over 2 is, the square root of 4 is 2. 2 to the power of 5, 2, 4, 8, 16, 32. So I've got 2 times 32, which is 64. 64 minus 20 is going to be 44. So it's 28i minus 44j.